C3 Trigonometry 2 example 14. Another trig equation with a double angle and a single angle. First job is to make all the angles the same throughout the equation. So sine 2x is going to be replaced with 2 sine x cos x, times it by the 2 that's already there, and we get 4 sine x cos x on the left hand side. On the right hand side we've got 3 tan x, which means at the moment we would have sine and cos and tan. So let's replace tan x with sine x over cos x. At least now we only have 2 trig functions instead of having 3 trig functions. I'm just going to multiply both sides by cos x to get rid of this fraction. So it's 4 sine x cos squared x equals 3 sine x. Now at this point we have a choice to make. We can either replace cos squared with 1 minus sine squared. That'll give us a cubic in sine x. Alternatively, we could rearrange the equation so that everything is on one side and then factorize out a common factor of sine x and then solve it from there. The way I'm going to do it is I'm going to replace cos squared x with 1 minus sine squared x. So cos squared x is the same as 1 minus sine squared x. That's using the C2 identity. Cos squared x plus sine squared x equals 1. Now let's get rid of the brackets. You can see we're going to end up with a cubic in sine x, and we're going to have some like terms we can collect as well. So here we'll have 4 sine x times 1, and then take away 4 sine x times sine squared x, so 4 sine cubed x. Some like terms here on the left and the right. We've got some sine x's. It's important that I don't divide by sine x. In this question, sine x could equal 0. All you've got to do is look at this last line to know that sine x equaling 0 is a possibility. Because if it was 0, all 3 terms here would equal 0, and we'd get nothing equals nothing, which is true. So therefore sine x could equal 0. Therefore must not divide by it, because we can't divide by 0. So let's collect all the like terms together. If I take away 3 sine x from both sides, on the left I'll just have 1 sine x. I've still got the minus 4 sine cubed x. Now it's a cubic. Of course, I mustn't divide by sine x. Instead, we must factorize. So bring out a common factor of sine x. And then inside the brackets we have 1 minus 4 sine squared x equaling 0. 2 possibilities here. Either so sine x is nothing, and just by thinking about the graph of sine x, we can write down all the answers for this part between nothing and 360, and the question says we can include nothing but not 360. So where would sine x equal 0? Well, that will happen when x is nothing, or 180 degrees, or 360, but the question says we're not allowed to include 360 as one of our answers. So there we've got 2 solutions already. There will be some more from the other part of this line. So the other possibility is 1 minus 4 sine squared x equals 0. That comes from inside the brackets. If that were true, let's rearrange it, and we get 1 equals 4 sine squared x, and then a quarter would equal sine squared x, and then square root both sides, remembering plus or minus. So the square root of a quarter is a half, because the square root of 1 is 1 and the square root of 4 is 2. We need to remember plus or minus. At this stage, I'm going to draw a cast diagram to get all the solutions. The question says we need to be in degrees, nothing to 360. Now sine x could equal positive a half or negative a half. Therefore, we're going to find solutions in every quadrant, because it could be positive, so that includes A and S, or it could be negative, so that includes T and C. So each angle here that I've drawn on to the horizontal, they're all the same size, and I've called it alpha, and the size of alpha is given by inverse sine of a half, which you should know is 30 degrees. Our calculator will remind you. Inverse sine of a half is 30 degrees. So now we can look at my cast diagram and write down all the solutions between nothing and 360. So we have 30 degrees. The next one would be 180 minus 30, so 150 degrees. And the next one would be 180 plus 30, so that's 210 degrees. And finally, the last one, almost all the way around, less 30 degrees. So 360, take away 30, 330 degrees. So this question we got 6 solutions in the end. And hopefully you should have a little bit of time in the exam to check these at the end by putting them back into the original equation and seeing if they give you an equation that is true.